So future value of an annuity. That's how you pronounce that word, annuity. What is that? We'll see in a sec. But as I just mentioned before in the previous video, we don't usually just put a little bit of money and let it grow till the end. We kind of put a little bit of money from my paychecks or something to make it a big chunk of money at the end. Now, for this formula we're going to give you to work, there's some conditions. And here are the conditions. Please write this down for your summary. Annuity is a series of equal payments or deposits earning compounded interest and made at regular constant intervals. So you're putting $100 every month, or you're putting $250 every 2 weeks. Every 2 weeks is kind of an important one because that's like our paycheck. So it's got to be the same amount. If you put a little money later and a little more later, our formula will not use. Not that it's a bad thing, but just keep in mind that for your real life, you want to save the same amount every time and have it automatically deducted from an account or from a checking account, and then you make sure it happens. If you wait until the end of the month to figure out how much you got left, you're not likely to be very good at saving. All right, simple annuity means that the compounded period and the payment period are equal, and that's probably the wrongest one for real life. So that means that if it's compounded monthly, you're putting money per month. Or if you're compounding semi-annually, you're putting money only twice a year. Compounded annually, you're putting money only once a year. That's probably not very realistic, but it's not a bad approximation. And ordinary means that you put the money at the end of the period. So if you say, okay, I'm paying monthly, but I put it at the end of the month. I'll pay every 2 weeks, but I put it on the last day of the 2 weeks. And that just means that we're gonna have one less period. It's okay. So here's an example. If, we're gonna cover this with, this is not good. Napkin, because I'm in the living room right now. So if you have, if you put money 4 times a year, $1,000, and it pays at 6%, the last amount you put down gives you no interest because you just put it and then you check how much you got. 3 years, it gives you 1 year of interest. So 0.6 to the power of 1, that's 60. This one will give you 2 years of interest because it takes 2 years for it to mature. And this one will give you 3 years, and that's why you 3. Now, your bank account doesn't work like this, that you got 3 different accounts or 4 different accounts. It's all together. So then we just add it together and you will end up with 4,374.62. Now, of course, you really just put $4,000, but you end up with 4,374.62 because they paid you interest. They paid you more interest on the amount that you put at the very beginning and no interest on the one at the end. Right? And that's fine and dandy. But again, if you want to do this compounded monthly, well, you have to do that 48 times. So here's the formula that we're going to use to get that same amount or same number in one shot. PMT, which I usually write as R, is regular payment. So this is the amount that you put down every time. So that will be 1,000. 1 plus I, you already know I. Actually, you know the rest of them. The rest are all the same. FV stands for future value. How much is it all together? So let's look at that example. On the example that we just did, the future value, we don't know what it is. The payment is 1,000. I is 0.06. Now we don't need to change that because 0.06 is annual interest rate. So that's if they pay you 6% per year, they pay you 6% per year. And N is 4 because it's 4 years compounded annually. So how many years are there in 4 years? Just 4 years. To plug this in, it's a little trickier than it may seem. I just look at 3 numbers. So I look at the number on top, I hit enter, divided by open bracket. You do want to use brackets on this, enter, and then multiply by 1,000. Please make sure that you know how to plug this in. For this one, you're not going to have too much trouble. The next one will give you a little bit more trouble. So here we go. Let's go on to the next one. Usually I just ask students about, okay, how much can you save and what interest rates, blah, blah, blah. So we got this one from last class. If you save $250 per month at 6.1 compounded monthly, how much can you leave it there for? And I just made up a 50 years just to make it really impressive. So 250 every month for 50 years at 6.1. How much money will you have? Notice that per month and compounded monthly have to match for our formula to work. So payment is 250. The I is 0.61 divided by 12 because it's per month, right? So if you pay me 6.1 for 1 year, for every month, it's only a 12th of that. And how many months are there in 50 years? 12 times 50 is 600. So when you plug it into equation, it should look like this. and then make sure that you can plug it in and get your number. This would be your answer. So just under $1 million. Not too shabby. One more example, just in case, and then ask you about interest rate. If you can save $55 every 2 weeks from every paycheck and invest it at 4.3% per year compounded bi-weekly, so every 2 weeks, and let's say you can live there for 6 years. So for like when you graduate from university, how much money would you have? So if just $55 every 2 weeks, so payment is 55. This is 0.043 divided by 26 because every bi-weekly period would be this amount. And how many bi-weekly periods are there in 6 years? Well, there's 26 periods per year, and times 6, 156. So when you plug it in, here's your formula. Again, make sure that you do know how to do it. Probably the biggest challenge, and it's almost $10,000 that you would get by just investing $55. But how much was it in interest? And this is a little different because interest here is going to be like how much I paid versus how much I took out. We know we took out $97.79, but how much money did we put in? Oh wait, we put in $55 156 times. So if we just figure that out, $100 and 56 times, that's how much money we put in, $85.80. But we took that out. So the difference between those two will tell us that, oh, we made just under $1,200 in interest. So most of it was the money that we put in directly. Let me just finish with this. Remember that we said we're going to be building on the formulas. Now we have the lump sum formulas on top, P and A, and now we have the future value formula at the end here. So this little symbol here means that we've got the regular payments. This symbol for me means that I just put the money only once. This is the money I'm going to get at the beginning. This is the money I'm going to get at the end for the nice little flags.